This topic is ninth graders' nightmare, but not anymore. Watch this video. So in today's session, we are going to discuss about trigonometrical ratios. See, what is trigonometry? Now, trigonometry is actually a branch of mathematics which deals with the study of right angle triangles. Now, this is what your textbook will say. But what actually it means and what is the purpose of trigonometry is a slightly different story. Now, since we are going to only talk about the exam point of view, let's understand we need right angle triangles. If we study about right angle triangles, it's called as trigonometry. Okay. Now, this is a very, very vast topic. A part of it is being taught to you in 9th standard. The rest of it is going to be taught to you in your upcoming levels, maybe in your 10th standard, 11th, 12th, and so on. Okay. So let's see what we have in today's class. Okay. Just look at the board. We have a right angle triangle here. Let's name it as A, B, and C. Okay. Now, out of the three angles, now one angle is already marked as 90 degrees. Since I said it is a study of right angle triangles, so I have already marked angle B as 90 degrees. Now, we have another two angles with us. Okay, angle A and angle C. Now, if we take any one particular angle into consideration, let us say I take angle C into consideration and I call it as theta. Okay. Now, with respect to theta, we'll have to first name the sides of this triangle. Now, how do we name the sides of the triangle? Now, observe carefully. The right angle is touching the side AB and BC. The only side which is not being touched by the right angle is AC. And that side is always called as the hypotenuse. As all of us already know, that side is called as the hypotenuse. Okay. Now, the two sides which are touching the right angle has to also be named. Okay. Now, how are we planning to name that? Now, observe carefully. This theta is touching BC. It is touching AC. But AC already has a name as the hypotenuse. So the other side which is being touched by theta is called as the adjacent side. And the side which is not touching theta, the side right opposite to theta, is called as the opposite side. Yes? Okay. So we have a right angle triangle. One angle is already 90 degrees. So out of the remaining two angles, we take one angle into consideration. And with respect to that angle, I have marked the opposite, adjacent, and hypotenuse. The side which is touching theta is called as the adjacent side. The side which is not touching theta is called as the opposite side. The side which is right in front of 90 degrees or the side which is not touching the 90 degrees is called as the hypotenuse. Now, with respect to this right angle triangle, we need to learn few ratios. As the chapter says, trigonometrical ratios. So we need to learn few ratios. Now, we have categorized the ratios into two parts. Now, we have basic ratios. We also have derived ratios. Now, what is the meaning of basic ratios? The meaning of basic ratios is that these ratios, whatever we are going to learn now, is for us to remember as it is. We should not sit and think as to how they have got this, from where they have got this, how are we planning to derive this, who derived it. All that is not necessary for us. There are just two basic ratios which we have to just remember as it is. For example, the first ratio is sine theta. The full form is SINE. Sine theta. Sine theta is defined as the opposite side divided by the hypotenuse. The opposite side divided by the hypotenuse. And in our diagram, the opposite side is AB and the hypotenuse is AC. And I'm going to leave a blank here, which I'm going to fill later. I'll tell you what that blank is later. Okay. So sine theta, the first thing that has to come into your mind is, if somebody is talking about sine theta, it's always opposite by hypotenuse. So opposite by hypotenuse defines sine theta. Okay. The second basic ratio is cos theta. The full form is cosine. So we read it as cos theta, but the full form is cosine. So cosine theta or cos theta is defined as the adjacent side divided by the hypotenuse. The adjacent side divided by the hypotenuse. So in our diagram, the adjacent side is BC and the hypotenuse is AC. The hypotenuse is AC, and as usual, I'm leaving a blank space to fill later. Yes. So these are the only two formulas which you just have to remember as it is. The remaining formulas, the remaining ratios can be got using these two ratios, can be derived using these two ratios, and that is why the remaining ratios are going to get a name as derived ratios. They are no more going to be called as basic ratios. So I am going to call them as the derived ratios. So let's continue from here. We have written two ratios here. So let's continue with the third one. Okay. So the very first derived ratio is tan theta. The full form is tangent. Tangent or tan theta is defined as simple as sin theta divided by cos theta. So sin theta divided by cos theta. In other words, sin theta was opposite by hypotenuse. Cos theta was adjacent by hypotenuse. So hypotenuse gets cancelled. So my answer is opposite by adjacent. So in my diagram, opposite is AB and adjacent is BC. So AB by BC. Also with a blank here. Yes. The next ratio is cot theta. The full form is cotangent. Cotangent. Now, if sine by cos has a definition called as tan, so obviously cos by sine also should have a definition. So cot theta is defined as cos by sine. So very clearly it's the reciprocal. See here, sine by cos is tan. So cos by sine is cot. So it is the reciprocal of tan theta. It is the reciprocal of tan theta, right? So what is tan theta? Opposite by adjacent. So I can directly write adjacent by opposite, the reciprocal. So what was tan theta? AB by BC. So I can directly write BC by AB. Now guys, please concentrate. If I take these two parts into consideration, if I say cot theta is equal to 1 by tan theta, I'm writing here, cot theta is equal to 1 by tan theta. Am I allowed to swap these two? I can cross multiply, I can bring tan to the numerator, and I can take cot to the denominator, isn't it? I'm sure you guys understood, right? So what is tan theta getting a new formula like? Okay, so tan theta is getting a new formula called as 1 by cot theta, and that is the blank that I've left there. So tan theta can also be written as 1 by cot theta. 1 by cot theta. Like how we wrote cot theta as 1 by tan theta can be written as 1 by cot theta, right? Okay, so let's see the remaining derived ratios. So the next derived ratio, is called as cosecant theta. Cosecant theta. I write COSEC, but the full form is cosecant. Cosecant theta is as easy as the reciprocal of sin theta. Cosecant theta is defined as the reciprocal of sin theta. In other words, sin theta we got opposite by hypotenuse. So directly I write hypotenuse by opposite. Sin theta was written as AB by AC. So I directly write AC by AB. Right? Now, just like how we did for cot and tan, same rule applies here. If you try to equate these two, cosecant is equal to 1 by sine. So sine can come to the numerator here, cosecant can go to the denominator. Those two can interchange their places. So sine theta gets a new formula called as 1 by cosecant theta, right? So that is the blank that I have left here. So 1 by cosecant theta. 1 by cosecant theta. And the last ratio that is there for us is secant theta. Remember guys, this is not read as sec theta. This is read as secant theta. This is not read as cosec theta. It is read as cosecant theta, right? Now, secant theta is the reciprocal of cos theta. Like how sine had a reciprocal, cos also has a reciprocal. So 1 by cos theta is defined as secant theta. So what was cos theta? Adjacent by hypotenuse. So right now I write hypotenuse by adjacent. What was cos theta? BC by AC. So here I write AC by BC. And if I apply the same logic here, cos and secant can swap their positions. So cos theta becomes 1 by secant theta. Yes. So what are all the important formulas? What are all the important things that we have to remember? Literally everything except this AB, AC, BC, except for that, because depending on the diagram, those alphabets may change, isn't it? Okay. So that we don't have to by heart, that we don't have to remember. But other than that, you know, we'll have to remember things like, if I ask you a question, like if somebody asks you a question, what is tan theta defined as using sides? So immediately you should say opposite by adjacent. So what is tan theta defined as using basic ratios? So you'll have to say sine by cos. What is tan theta defined using another derived ratio? So you will have to immediately say tan theta is 1 by cot theta. Tan theta is 1 by cot theta. So everything has to be there on your fingertips, right? So only sine and cos are called as basic ratios. Tan, cot, secant, cosecant, these are called as derived ratios, because you saw me deriving all these formulas by just using sine and cos values, right? Okay, now these are all the do's. These are all the actual formulas. But let's even talk about the common errors, the common mistakes what students do. Basically, the don'ts. Throughout this explanation, I'm sure I never ever mentioned that sine theta is the reciprocal of cos theta. I never mentioned anything like this. Never ever I have written sine theta is the reciprocal of cos theta or cos theta is the reciprocal of sine theta. Not true, right? So I have seen lot of students writing 1 by sine as cos. They see 1 by cos, they immediately write sine. So this is not true. So that is not correct. Okay. Now the second mistake is with respect to these two formulas. The minute we ask a question based on cosecant theta, comfortably many students say 1 by cos. And when we mark it incorrect, they try to argue with us saying that no, this is only right. Reason is cosecant starts with C and cos also starts with C. And to support their argument, they say, sir, even secant theta is the reciprocal of 1 by sine theta because secant starts with S, sine also starts with S. Absolutely incorrect. Absolutely wrong. So how I ask you to remember is, if it is cosecant which starts with C, then it is the reciprocal of sine which starts with S. So if it is S, it becomes C. If it is C, it becomes S. That's how you're supposed to remember. If it is sine, it has to change. Sine, S, has to change into cosecant, that is C. Cos, that starts with C, has to change into S, that is secant. That's how you have to remember. So this part of it, you have to actually be very, very careful. So this part of it, you should never ever try to use when you're trying to solve questions. We have never learnt anything like this. So what is important for us is sine theta is opposite by hypotenuse, or in terms of derived ratios, it is 1 by cosecant. Cos theta is adjacent by hypotenuse, or in terms of derived ratios, it is 1 by secant, right? So tan theta is sine theta by cos theta, or in terms of sides, it's opposite by adjacent, or in terms of another derived ratio, it is 1 by cot theta. Similarly, cot theta is cos by sine. In terms of another derived ratio, it is 1 by tan, or in terms of sides, it is adjacent by opposite, right? So cosecant theta is 1 by sine, that is cosecant in terms of basic ratios is 1 by sine, and in terms of sides, it's hypotenuse by opposite. Secant is a derived ratio, so in terms of basic ratios, it is 1 by cos, and in terms of sides, it is hypotenuse by adjacent. This, if you write and practice, if you try to write and practice twice or thrice, or if you try to apply these ratios to few questions and practice, it will easily register in your mind. Now we are going to practice few questions just to see whether we have got comfortable with the ratios. So let's start with the questions. We've taken a basic question, okay? Now we have two right angle triangles here. So ABD is the first right angle triangle and BDC is the second right angle triangle. Now the question is asking us to find cos A. The question is asking us to find cos A. So I told you, right, one angle has to be taken into consideration. So the angle taken into consideration is A, right? So what we do is we just separate this right angle triangle from the entire figure. So what I do is I draw a tiny right angle triangle like that. Yes, so this is ADB. This is given as 3, this is given as 4. Yes, before I look into the question, I complete the other side. So how do you calculate the hypotenuse? By using Pythagoras theorem, right? So how do we apply Pythagoras theorem? Square on the hypotenuse, that is AB square, is equal to sum of squares of the other two sides. So 3 square plus 4 square. So AB square is equal to 25. So AB is equal to square root of 25, which is 5. So I write 5 here and then look at the question. So what is the question asking us to find? The question is asking us to find cos A. The question is asking us to find cos A. So if we recollect, if we go back and if we recollect, what is cos formula? Adjacent by hypotenuse. So adjacent by hypotenuse. We'll have to first find out which is the adjacent side and which is the opposite side or hypotenuse. Okay, now concentrate here. So with respect to A, this is the opposite side, this is the adjacent side, and this is the hypotenuse. So what did our formula tell us? Adjacent by hypotenuse. So adjacent by hypotenuse. So the answer is AD divided by AB. So the answer is 3 by 5. That's it. As simple as that. Okay. So let's see the next question. So tan square A minus secant square A. Again, A belongs to this triangle only. So I can still use this triangle itself. The question is tan square A minus secant square A. Let's see how to do this. So go back and see what is tan formula. What was tan formula? It was opposite by adjacent. See there, it is opposite by adjacent. So come back. So which is the opposite side here? 4. And what is the adjacent side here? 3. So 4 by 3 the whole square. Whole square is because of the square present here. Minus. What is secant defined as? Hypotenuse by adjacent. So go back and check. Secant is defined as hypotenuse by adjacent. So let's apply hypotenuse by adjacent. Hypotenuse is 5, adjacent is 3. So 5 by 3 the whole square. So let's simplify this. 16 by 9 minus 25 by 9. So the LCM is 9. 16 minus 25. So it is minus 9 by 9. So the answer is minus 1. The answer is minus 1 for the second part. We have got the second part, right? Okay. And the third question here is cot square C minus 1 by sine square C. So cot square C minus 1 by sine square c. As a normal student, I am not comfortable with fractions. Let us say I don't want fractions in my question. So I don't want this 1 by sine. So if you go back and see what is 1 by sine, 1 by sine is nothing but cosecant. So I can immediately write cosecant. Instead of this, I can immediately write cot square c minus cosecant square c. That makes it more comfortable for me. And C, angle C belongs to which triangle? It belongs to this big triangle, right? So if you separate this big triangle from the diagram, the triangle is here. Yes. So this is D, B, and C. This is the angle into consideration. Now, they have given 4 here. They have given 12 on the hypotenuse. So can we calculate this side as usual by Pythagoras theorem? Yes. So 4 square plus CD square is equal to 12 square. So CD square is equal to 144 minus 16. So CD is equal to 128 with a square root. 128 with a square root. Now CD is equal to square root of 64 into 2. So CD becomes 8 root 2. Reason is, you know, square root of 64 is 8. So 8 root 2 is the simplest form of CD. So I write 8 root 2 here. So 8 root 2. Got it? Now, concentrate here. With respect to C, let us see which is the opposite side, which is the hypotenuse, and which is the adjacent side. Okay? So with respect to C, this is the hypotenuse. This is the opposite side, and this is the adjacent side. 8 root 2 is the adjacent side. Now come back to the question. Cot. Cot is defined as adjacent by opposite. Do you want to cross check? Please observe. Cot is defined as adjacent by opposite. So let's apply adjacent by opposite. Adjacent is 8 root 2. Opposite is 4 with a whole square. Minus. Cosecant was defined as hypotenuse by opposite. So hypotenuse is 12. Opposite is 4 with a whole square. Now carefully solve this. 8 square is 64 into square root, root 2 the whole square is just 2. 4 square is 16 minus 12 square is 144. 4 square is 16. Right? Now you can try and simplify this. 16 once, 16 4 times. 16 once, 16 9 times. So what's left out? 4 2s are 8 minus 9. This also, the answer is coincidentally the same, minus 1. So we got the first answer as 3 by 5. We got the second answer as minus 1. And third answer also is minus 1 coincidentally. I hope you understood how I solved this question. This was just a very basic question. Okay. So we'll see more examples for you to get comfortable. I think you are trying to get an idea about what is happening. So we'll see more examples. Please concentrate. We have a question where there is no diagram given. At least in the previous question, there was a diagram, right angle triangle given. Now here we have a question without a diagram. So this is the only information given to us. So 4 cot A is equal to 3. You have to make sure that the ratio does not have any coefficient, meaning it does not have any number sticking to it. So this 4 is not allowed. So what do? I send the 4 to the other side. So I write cot A is equal to 3 by 4. And I draw a right angle triangle voluntarily. That is, I just draw a random right angle triangle. I mark some angle as A. There is A here, right? So I mark some angle as A. And what is the formula for cot? What was the ratio for cot? Cot was adjacent by opposite. So adjacent by opposite. So with respect to A, this is the adjacent side. So adjacent side, I'm supposed to mark 3. Opposite side, this is the opposite side, I'm supposed to mark 4. So this is adjacent, this is opposite. Yes. So from what was given, I got 3 here, I got 4 here. Now, as usual, I can apply Pythagoras theorem to get this side, right? So if I call this as A, B, C, so as usual, if I apply Pythagoras theorem, so I am going to get this as, see here, AC square is equal to 3 square plus 4 square. So as I did in the very first question, so AC I get as 5. So I'm going to get 5 here, right? And this is called as the hypotenuse, right? Now I go to the question. Question is very simple. Cosecant square A. So what did our formula list tell us? Cosecant means hypotenuse by opposite. You will have to recollect. Hypotenuse by opposite. So hypotenuse is 5, opposite is 4. So I can directly write 5 by 4 the whole square because of the square present here. Cot theta. What did our formula tell us? Cot. Cot was defined as adjacent by opposite. So adjacent is 3, opposite is 4. So 3 by 4 the whole square. So try to simplify this. This is 25 by 16 minus 9 by 16. So 16 is the LCM. 25 minus 9. So this is minus 16 divided by 16. Answer is minus 1. Right? Okay, this was a very simple question, but I'm trying to tell you that even if the right angle triangle is not given to you, you'll have to draw a triangle by yourself and you'll have to solve. Okay, let's see more examples. You'll have to stay in pace. You'll have to keep recollecting the formulas. Then only this will become interesting for you. Okay. Now, so cos A and sin B. Now, two values are given to us. And again, there is no diagram given to us. Please understand, there is no diagram given to us. Okay. Now, if I try to draw a right angle triangle and if I try to mark this as A, now as per my formula, cos is adjacent by hypotenuse. So if I take the adjacent side as 1 and if I take the hypotenuse as 2, I'm okay with all this, but what do I do with this? I can't again take, see what will happen if I again take B here, according to that formula, opposite by hypotenuse. The hypotenuse changes to root 2. One hypotenuse cannot have two different numbers. Here it is saying 2, there it is saying root 2. So one hypotenuse cannot have two different numbers, isn't it? So it simply means you have to draw two different right angle triangles. So in the first triangle, I've taken angle A into consideration. In the second triangle, I take angle B into consideration. As simple as that. So now with respect to B, the opposite side is 1 and the hypotenuse is root 2. Yes? So as usual, apply Pythagoras theorem and try to calculate the other side. Let's take this as x, let's take this as y. Okay, now try to do this. So x square plus 1 square is equal to 2 square. So x square is equal to 4 minus 1. So x square is equal to 3. X is equal to square root of 3. So immediately put square root of 3. Similarly, do this here. So y square plus 1 square is equal to root 2 the whole square. So y square plus 1 is equal to 2. Square root of 2 the whole square is 2. So subtract 1 on the other side. So y square is equal to 1. Y is equal to square root of 1, which is again 1. So I got y as 1. Now again, with respect to A, this is the opposite side. This is the adjacent side. And this is the hypotenuse. With respect to B, this is the opposite side, this is the adjacent side, and this is the hypotenuse, right? We need all these, we need to remember all these things, then only we can start with the question. Now, let's actually take a look at the question. Question says tan A. The minute you see angle A, you realize they are talking about the first triangle. They are talking about the values given in the first triangle. So what is tan defined as? Tan was defined as opposite by adjacent. So in the first triangle, opposite is root 3, adjacent is 1. So it's as easy as root 3 by 1 minus tan B. The minute you see B, so you realize it is the second triangle, right? So again, tan formula is opposite by adjacent. Opposite is 1, adjacent is also 1. So 1 by 1 divided by 1 plus tan A we got as root 3 by 1, which I can write as root 3 only. Tan B I got as 1 by 1, which I can write as 1 only. Correct? So what is this? In simple words, this by 1 is not necessary, right? So in simple words, this is root 3 minus 1 divided by 1 plus root 3 into 1 is just root 3. So can I change this and write it as root 3 minus 1 divided by root 3 plus 1? Because 1 plus root 3 or root 3 plus 1 both mean the same. Now this cannot be my answer, because what did your first chapter in mathematics teach you? That you cannot have roots in the denominator. You need to rationalize the denominator. So what is the rationalizing factor for this term? So it is root 3 minus 1 divided by root 3 minus 1. So what do you get here? Root 3 minus 1 becomes root 3 minus 1 the whole square. Root 3 plus 1, a plus b into a minus b is root 3 square minus 1 square. I hope you guys are following. So this is a minus b the whole square. Slowly do it. A square plus b square minus 2 into a into b. I'm sure you're understanding. Root 3 square is 3 minus 1, right? So let's solve this. Please concentrate. So root 3 whole square is 3 plus 1 square is 1 minus 2 root 3 divided by 3 minus 1 is 2. You are allowed to add these two terms but not with this. So what do you get? 4 minus 2 root 3 divided by 2. Right? Now what is the common factor here? 2. So remove the common factor. Remember, you are not allowed to cancel 2 and 2. You are not allowed to do that. So I removed the common factor 2 here. So 2 2s are 4 and 2 1s are 2. So I have 2 minus root 3 divided by 2. Now this 2 and this 2 can get cancelled. And what's my final answer? 2 minus root 3. 2 minus root 3. This is my final answer. As simple as that. So what did you learn newly in this question? If there are two values given with two different alphabets, you were supposed to draw two different diagrams, two different right angle triangles in other words. And depending on the question, if you see if you see one alphabet, go to the respective triangle and substitute values. If you see the other alphabet, go to the other triangle and substitute values and solve carefully. You should be able to get the right answer. And the right answer is 2 minus root 3. I hope you guys are following. Okay, so let's solve more questions. Again, there is no diagram given and they're asking us to find such a big value. Okay, now let's talk about this. Cosecant theta is equal to root 5. There is no coefficient here for me to bring it down. So can I simply say by 1? Doesn't make a difference. I'm sure it doesn't make a difference. So draw a random right angle triangle. Call one angle as theta. What is the formula for cosecant? What was the ratio for cosecant if you remember? Hypotenuse by opposite. So hypotenuse is root 5 and opposite was 1. So this is the hypotenuse, this is the opposite. Now using Pythagoras theorem, let's calculate the adjacent side. So x square plus 1 square is equal to root 5 the whole square. So x square plus 1 is equal to 5. So shift. So x square is equal to 4. So x is equal to square root of 4, which is 2. So I got x as 2 and this is my adjacent side. Right? So if we have all this ready with us, if you remember what I told you some time back, we are not comfortable with this fraction. So I want to convert the fraction now. So what is 1 by sine? We learnt 1 by sine is nothing but cosecant. Cosecant, there is a square here, so cosecant square theta. Similarly, what was cos by sine? It was cot. So there is a square here, so I can write cot square theta. So now let's do the substitution. 2 plus. What is the value of cosecant theta? You can either take it from the diagram or they have already given you cosecant theta as root 5. So you can go with that value itself. So cosecant theta is root 5 the whole square. Even if you take from the diagram, you'll get the same thing. Okay. Now, what is the formula for cot? Cot was adjacent by opposite. So adjacent is 2 and opposite is 1. So 2 by 1, the whole square. In simple words, it's 2 plus root 5 whole square is 5 minus 2 square is 4. So 2 plus 5 is 7 minus 4. A very, very, very simple question. I hope you guys are enjoying. Okay. So if you are able to recollect the formulas, then this will become very, very comfortable for you. So for recollecting the formulas, the only way is practice sincerely. Okay. So let's go to the next sum. Okay. So you have again two right angle triangles here. So this is the first right angle triangle. This is the second right angle triangle. Now, depending on the question, we need to choose, okay, the right angle triangles. Okay. So some values are missing here. Okay. So we'll solve the next question and we'll come back to this. Okay. The so-called toughest sum in your trigonometrical ratios chapter, okay, in the 9th standard trigonometrical ratios chapter. Students say very, very difficult sum, but whether it is difficult or easy, we are going to actually check right now. Okay, please concentrate here. So they have asked tan DBC. They have given all this. What we will do is, using these two numbers, let's first get AC by our regular Pythagoras theorem method. So AC square is equal to 4 square plus 3 square. So this is AC square is equal to 25. So AC is equal to 5. So this entire AC I'm getting as 5. Okay. The question is find tan DBC. DBC, this angle only. So if I take that as X. Okay. So let angle DBC is equal to X. So how do I find DBC? Now for finding tan DBC, I need parts of this small triangle. I need this part and this part. Without those two parts, I cannot actually solve. I can't take these big numbers and solve. Now, if you're a person trying to tell me that, sir, there is a perpendicular here, so 5 will get bisected into 2.5, 2.5, not correct. Okay, so it is not mentioned anywhere that line, this dB is bisecting the hypotenuse. It's not mentioned anywhere. So you cannot do all those things. Then what is this method? This is a totally new category of question. So what is the method that we apply here? So please concentrate how and what we apply here. Please concentrate here. So what we do is, by chance, see, just because this X is belonging to this tiny triangle, it's sounding difficult for us to solve. By chance, this X was present as one of the angles of the huge triangle, the big triangle. It would have been very simple for us. Reason is, all the parts of the big triangle are known to us. So that's what we are keeping in mind and proceeding. Please concentrate here. If this angle is X and the entire angle is 90, how much is remaining? 90 minus X. Now I take this triangle into picture. Sum of angles concept. So 90 minus X plus 90 plus angle A is equal to 180 degrees. We all know angles of a triangle add up to 180 degrees. So 90 plus 90 is 180 minus X plus angle A is equal to 180. Now if 180 goes to the right, it gets subtracted. So 180 gets cancelled. So what is angle A now? Minus X goes to the right and becomes plus X, right? So in simple words, they have asked us to find tan of DBC, which is same as tan of X degrees, because I have taken DBC as X. I have taken DBC as X. Now, which is still same as, what is X also equal to A? So I can still say tan X is same as tan A. Now the question becomes very simple. You have a huge right angle triangle, see here. You have a huge right angle triangle. This is angle A. The sides are given to you. This is 4, this is 3, and this is 5. Yes. So with respect to A, which is opposite, this is adjacent, this is hypotenuse. What is the formula for tan? Opposite by adjacent. So my answer is as easy as 3 by 4. Why was it sounding difficult in the beginning? Only because x belonged to, that DBC belonged to a tiny triangle. So what am I doing? I'm making that same x equal to one of the angles of the large triangle. I'm making x equal to one of the angles of the large triangle. I made x equal to a. So I got this x here. And now it became as easy as tan x, which is tan A. Tan A is as easy as opposite by adjacent. So 3 by 4 is the final answer. We'll do the same thing for sine dBA. Please concentrate here. So let dBA, or not necessary, dBA, we already have 90 minus x, right? So we can see 90 minus x here. So we already know that dBA is 90 minus x. So no need of writing let. Okay. So we know dBA is 90 minus x. Now we need to check where else can I get 90 minus x. So what I do is I move to the opposite triangle. Please concentrate. In triangle DBC, carefully, 90 plus x plus 90 plus x plus angle C is equal to 180 degrees, right? So subtract on the right side, take both and subtract. So angle C is equal to 180 minus 90 minus x. So angle C is equal to 180 minus 90 is 90 minus x, which is same as dBA. So the question is asking for sine dBA. So sine dBA is same as sine of angle C, right? So what is sine of angle C? C is taken into consideration now. This is C, this is B. So with respect to C, the diagram changes, isn't it? So with respect to C, if I try to draw a right angle triangle, this is C here. So 4 here, 3 here, and 5. So with respect to C, this is the opposite side, this is the hypotenuse, and this is the adjacent side, right? So what is sine formula? Opposite by hypotenuse. So as simple as 4 by 5. Why was I not allowed to use this same diagram? Reason is because here the angle into consideration was A. Okay. I want the angle into consideration as C. So I have to use a different diagram. Got it? So as easy as tan A 3 by 4 and sine C 4 by 5. So you will have to do it this way. So if you try to stick on to the small triangle, then you are going to find this question very difficult. So if you try to move on to the large triangle, see, when I wanted this angle, I go to the opposite triangle and I start solving. Similarly, when I wanted this angle, I went to the opposite triangle and I started solving. Yes. So this angle was equal to some angle in the opposite triangle. Similarly, this angle was equal to some other angle in the opposite triangle. So if you try to practice this again and again, I'm sure even this question becomes easy for you, right? Let's try more. Look at this. You have a right angle triangle here, but you also have a triangle which doesn't look like a right angle triangle. Okay, so that is what is new in this question. Let's see what to do. Okay, now this is phi. This symbol stands for phi, P-H-I. And this is theta, you know very well, right? So find the value of sine theta and tan theta. So they want only theta. So am I allowed to use this triangle? No, the answer is no, because it's not a right angle triangle. So what do? I voluntarily drop a perpendicular. I draw a perpendicular here. Yes, I draw a perpendicular, I make it into a right angle triangle. Now this involves little number of steps. Okay, now please concentrate here. For this triangle, can we calculate CD using Pythagoras theorem? Yes. So if you try to calculate CD, so 13 square is equal to 12 square plus CD square. Yes, so 169 is equal to 144 plus CD square. So CD square is equal to 25. So CD is equal to 5. So you are getting CD as 5. Now, since this looks like a rectangle, the same 5 can also be marked here. So this is 5. The entire length was 14. The entire length was 14 and this length is 5. So how much am I going to get here? If I call this alphabet as P or something like that. Okay, so how much am I going to get here? 14 minus 5, which is 9. Right? Now this is given as 12. So since this is a rectangle, opposite side will become 12. Now using 12 and 9, can I calculate this? Yes, again using Pythagoras theorem. So if you apply Pythagoras theorem here, 9 square plus 12 square is equal to AD square. Right? So 81 plus 144 is equal to AD square. So AD square is equal to 225. So AD is equal to 15. So I got AD as 15. Right? Now the question is asking for sine theta and tan theta. So with respect to theta, let's draw that triangle individually. So this is the diagram. This is theta. This is 15 here, 12 here, and 9 here. With respect to theta, this is the opposite side, hypotenuse and adjacent. By now you should be comfortable with that, right? So what is sine theta? So sine theta is as easy as, if you remember, opposite by hypotenuse. So opposite by hypotenuse is 12 by 15. That's the answer. And what is tan theta? Tan theta formula was opposite by adjacent. So opposite by adjacent, 12 by 9, right? So you can simplify this. This is 4 by 5 and this is 4 by 3. These are the required answers, right? Now coming to the second part, write an expression for AD in terms of theta. Write an expression for AD in terms of theta. That means you know very well AD is the hypotenuse. So which ratio includes the hypotenuse in it? You know sine includes hypotenuse. Sine is opposite by hypotenuse. Or you can also stick on to cos. Cos is adjacent by hypotenuse, right? Okay. So let us say I go with sine. So sine theta. This was theta, right? So sine theta is, this is A, P and D. So sine theta is opposite by hypotenuse. So opposite is 12 divided by hypotenuse is AD. Opposite is 12 divided by AD, correct? So you have to write AD as 12 divided by sine theta. I just cross multiplied. I just swapped these two, right? So you can also write this as AD 12. What is 1 by sine? I don't want sine in the denominator. So you can write cosecant theta. 1 by sine is cosecant. So this can be one answer. That is because I have chosen sine. But we very well know we could have also chosen cos, because cos also has hypotenuse coming into picture. AD was the hypotenuse, isn't it? Okay. So if I would have chosen cos, so cos theta is equal to adjacent by hypotenuse. So adjacent is 9 divided by AD. So cross multiply. AD is equal to 9 divided by cos theta. So AD is equal to 9 secant theta. So this can also be your required answer. So either this or this, both are right for the second part. Got it? So what was new in this question? We did not have a right angle triangle. It was some other form of a triangle. We had to draw a perpendicular and make it into a right angle triangle. Okay, so let's try more. This is a very, very simple question. No values are given in the question, but this symbol indicates that D is the midpoint of AC, which means this part and this part are equal. And this side is also not given to us. Let's take it as Y. Let's take it as Y. Now the question is asking for tan of CAB divided by tan of CDB. Tan of CAB, CAB. That means I have to take the whole big right angle triangle. So with respect to the whole big right angle triangle, tan formula is opposite by adjacent. So with respect to A, opposite is y, adjacent is this entire side. So can I say y by 2x? Y by 2x divided by tan CDB. CDB is this angle, CDB. That means I have to stick on to only this tiny triangle, correct? So with respect to this angle, the opposite is y and the adjacent is just x, right? So how to simplify this? Y by 2x into, this goes to the numerator, right? So x by y. Y and y cancel, x and x cancel. So my final answer is 1 by 2. My final answer is 1 by 2. The same procedure we apply for this second part. Okay, so let's see what we do here. The question says tan ABC, tan of ABC divided by tan of DBC. So if I'm talking about ABC, this entire angle, so I take the whole big triangle into picture. What is the formula for tan? Opposite by adjacent. So what is the entire opposite side? It's 2x. So 2x by, what is the adjacent side? It is y. If it is tan DBC, this tiny triangle, this angle belongs to this tiny triangle. So what is tan formula? Opposite by adjacent. So opposite is x, adjacent is y. So x by y. So how to simplify this? 2x by y into y by x. X cancel, y cancel. So you have 2 as your final answer. Yes, guys. So I hope you guys are understanding. Okay. So just one more question so as to complete the concept. Okay. Look at the board. Okay. So the most important question from this trigonometrical ratios chapter is something like this. Okay. Again, you have two right angle triangles given to you. Some values are given 26, 10, and this entire side is 42. So let's actually separate the triangles and get ready with the triangles. So if this entire side is 42 and CD is 10, so how much is remaining here? This is 32, isn't it? Okay. So now I can use this right angle triangle and apply Pythagoras theorem here. So 26 square plus is equal to 26 square is equal to 10 square plus AD square, right? So this is 676 is equal to 100 plus AD square. So you get AD as 24. So you get this as 24. Now if you use Pythagoras theorem here, so 24 square plus 32 square is equal to AB square, right? Yes. So this is 576 plus, what is 32 square? What is 32 square, man? AB square. So this is 1600 is equal to AB square. So you have AB as 40. So this is going to become 40. Now we are ready with all the values. Let's start off with the question. Now the very first question is asking for 1 by sine square y minus 1 by tan square y. 1 by tan square y. As we have been mentioning from the beginning, we are not comfortable with the fractions. So let's go with converting the fractions. So 1 by sine is nothing but cosecant square y minus 1 by tan is nothing but cot square y. So since the question is talking about y, which triangle do we choose? Obviously this triangle. So let's keep a small reference here. So this is the triangle 40, 24 and 32. Y is here. So with respect to y, this is the opposite side, this is the adjacent side, and this is the hypotenuse. So let's do the substitution. Cosecant was hypotenuse by opposite. 40 divided by 24 the whole square. Cot was adjacent by opposite. 32 divided by 24 the whole square. So you can simplify this. 8 5 times, 8 3 times, 8 4 times, 8 3 times. So this is 25 by 9. 5 square is 25, 3 square is 9, minus 4 square is 16, 3 square is 9. So you have 9 as your LCM. 25 minus 16. So this is 9 by 9. The answer is 1. See, such a simple answer, right? So let's go with the second question. So what does the second question ask us to do? Please concentrate. So 6 by cos x minus 5 by cos y plus 8 tan y. This is a mixture of the first triangle as well as the second triangle. Now with respect to the first triangle, because x has been asked there, with respect to the first triangle, if you take a small reference here, so this is the first triangle, the reference is x is here, and you have 24, 10 and 26. So with respect to x, this is opposite, adjacent and hypotenuse, right? So let's do the substitution either directly or as usual, if we don't want fractions, we first convert the fractions and then proceed with the substitution. So I can write this as 6, 1 by cos is nothing but secant x. I can write this as 5 as it is, 1 by cos is again secant y plus 8 tan y. So let's do the substitution. 6. What is secant x? Secant was defined as hypotenuse by adjacent. So hypotenuse, since it is x, I go to this triangle, hypotenuse by adjacent. So 26 divided by 24 minus 5 into secant y. Y, I go to this triangle. Since it is y given there, I go to the other triangle. So again, the formula for secant is hypotenuse by adjacent. So 40 divided by 32. 40 divided by 32 plus 8 times tan y. So y again, tan is opposite by adjacent. 24 by 32. Right? So we need to simplify this. 6 once, 6 4 times, twice 13. 13 by 2 minus. So 8 5 times, 8 4 times, 25 by 4 plus 8 3 times, 8 4 times, 4 once, 4 twice. So 2 3s are 6. This is what I have. Okay. So what is this? LCM is 4. So 26 minus 25 plus this is 6 4s are 24. So 50 minus 25 is 25 divided by 4. So my final answer is 6 1 by 4. 6 1 by 4. Right? So you can either give it in decimals or you can give it in mixed fractions. Totally fine. So 6 1 by 4. This is one of the most important questions in the chapter. Right? Okay. So I hope you followed. Please practice the sums. I'm sure you will understand. Okay. So see you in the next video.